Hey guys, sorry that this is dark. It's dark in my room. It is late and I am still teaching. So today you are learning about correlation and regression. Actually, today you're only learning about correlation. It's going to be a fairly short lesson. We are going to talk about correlation. Now, correlation is the relationship between two variables. We are going to be looking at that throughout the chapter. Today, we're going to be talking about both the types of correlation and the strength. And then that's about it. Now, when we're doing this, you're going to be creating or constructing quite a few scatter plots, dot plots, those types of things. So you need to know what's your X variable and what's your Y. Your X is always your independent. This says it stands alone. I always think of it as the one that I'm choosing to test. So for example, in our Barbie bungee jump, the X variable is the number of rubber bands. I am choosing the number of rubber bands. I get to choose that. And then I'm measuring how far Barbie drops. That is going to be my Y variable. So your X variable is usually what you're choosing to test. The number of days you go between measuring plant sizes, something like that is your X variable. The height of the plant will be your Y. Now, we're going to look at correlation. You know, I always have to relate things because my brain cannot just think of things normally, I guess. First, we're going to talk about negative, positive, no correlation, or nonlinear. Now, I always think of graphs as roller coasters. I love to ride roller coasters. So if I was looking at this, we read things left to right. If I was looking at this going from left to right, this is a roller coaster that is going downhill. That's negative. It's going down. That means it's a negative correlation. Now, it's related to each other, but as X grows, Y decreases. A positive correlation looks like this. Again, if I'm going from left to right, I am riding a roller coaster. It's going up the hill. First hill on a roller coaster is always my least favorite. I have been told you guys are going to Cedar Point for senior skip day. I would love to come. Please invite me. So negative correlation looks like this. Positive correlation looks like this. Hopefully you can see that looks like a bunch of flies or mosquitoes. It is not a correlation at all. And hopefully you can also tell that this is not linear. So while they might be related, it is not a constant and it is not linear. These are the two that you need to be concerned with, definitely on your final. Let's construct a scatter plot. That way we can then see if we have any correlation. So I have it listed out on a second set of notes just so that I know where to start our scatter plot. So what we're going to do is we've got to put this is our X axis. It's the number of absences. That's what we're choosing to measure. And then this is my test scores. So if we're looking at the number of times you've missed my class, probably your test scores aren't as great as if you were here all the time. We are going to write the numbers down below. Notice it goes from 1 to 8. So I'm going to put 0 here and then do 2, 4, 6, and 8. Why did I skip the odd ones? Because I have large, ugly handwriting, and it was easier to put just the even numbers in. Then our y-axis has to go from about 50 to about 100. So I'm going to put 50 at this bottom line, then 60, 70, 80, 90, and 100. Again, I'm skipping the 5s because I don't have enough room to write those. Now we're just going to plot these. Here I have, if you missed 8 absences, then you got a score of 54. If you missed 3 days in my class, you get a score of 82. 7 days in my class, a score of 68. If you missed 3 days, a score of 91. That's not true at all. 6 days, a score of 65, 4 and 78, 2 and 93, 6 and 62, and 1 and 96. Now, hopefully when you look at these dots, you notice they're trending downward. We are later in the chapter going to find a line of best fit, but that looks about approximate. So hopefully you also will be able to see that this is a negative correlation. As my x-axis went up, my y-axis went down. So our interpretation, the more days you miss, the worse your score. Don't miss my class. All right, flip the page. Now, this, as much as I love math, looks miserable. We're not going to do that math, I promise you. So, but what we are doing is we do have to find a correlation coefficient. What this is it measures the strength and direction of a linear relationship. So it's going to, when we put all of this data into our calculator without us putting a scatter plot in, we're going to be able to find out how direct, or if this is a positive or negative correlation, and how strong that relationship is. R can only be between -1 and 1. When we put it into our calculator, we're going to get a number between those two numbers. We are never going to get a number larger than 1 or less than -1. Now, we can plot these, and we're going to, so that we can see visually what that correlation is. Then we're going to put it into our calculator. If you go to the back page of your notes, let's see, this page, I've shown you how to do the correlation coefficient so that you can always remember and never have to ask me again. So right now, you are going to take a second. You're going to plot this on here and this on this one. I want both of them plotted so that you can see those. You're going to be able to do this. X-axis, our x-axis is the weekly hours spent studying, and our y-axis would be our grades. We're measuring how many hours you spent. We don't know what your grade's going to be. Again, x-axis, number of absences, y-axis, test grades. So you are going to push pause on the video and put those into your notes. All right, so you've put these on your scatter plot. You can see that 1 is a positive correlation. If I was riding a roller coaster, I'd be going up the hill, positive, and 1 is a negative correlation. Now, we want to know what that R value is. So what we're going to do is we are going to put that into our calculator. The first thing that you're going to do is you are going to put this, our X, in list 1, and then our Y in list 2. So you're all taking the second to do that right now. All right, now that you have everything into your list, list 1 is my dependent data, or list, hold on. All right, so I was looking at the back of the notes, and I have that to put your independent data in one spot and your dependent data in another. It doesn't really matter as long as you know which one's which. So you've put these in list 1 and list 2. That's the key. Then you have to go to second catalog. Now, catalog is down here where the 0 is. So you're going to go to second catalog, and you are going to go down all the way to diagnostic on. So you have to go all the way down to these. You're going to have that arrow at diagnostic on, push enter, and then push enter again. It has to say done when you've done that. Then we're going to go to stat. We're going over to calc. And we want number 8. They're written in 2 different forms. And In stats, we write our line form in this a plus bx. So it's number 8. So you can either push 8 or go down to 8. I put my x value, it says x list. I put it in list 1, and then I put my y list in list 2. If you flip-flop them, make sure you know which one is your x and which one is your y. Our frequency list, we don't have one. We're going down to calculate, and we're going to push enter. And it's giving us our R. What we're looking for is our R value. So what this is my R value is equal to 0.70. And so what does that mean? What that means is this is positive. Notice it's a positive number, and it's slightly better than half. So it's not strongly correlated, but it's not bad. I'd say there's some correlation. The closer to 1 you get, the more there's correlation. The closer to 0 you get, the more there is no correlation at all. So there's some correlation. It's not strong, but it's not bad. Now, you're going to take a second and you're going to put all of these into list 1 and list 2. You're going to find your R on your own, and then we're going to come back together. All right, so you've now done the R value for this set of data, and you should have gotten an R of negative 0.96. Remember, it can't be anything more than 1, but holy cow, is that highly correlated because it's almost to 1. And notice the negative in front means that it's negatively correlated. So now you wouldn't even necessarily need to draw those pictures. You could just put it into your calculator. And that's what you're going to do for your homework. So numbers 1 through 4, you're just saying if it's a positive, negative, or no correlation. Then numbers, I think I had 11 through 20. I'm not positive. The sub will tell you. It's all data. You're just going to put it into your data, find your R value, and talk about what kind of correlation there is. Remember, the closer to -1, that's a stronger negative correlation. The closer to +1, it's a stronger positive correlation. The closer to 0, not much correlation at all. So that's what you guys are up to today. I hope you have a fantastic day. I miss you. Can't wait to see you tomorrow.